Hi, this is a video demonstration of a project for EEE3097S with course convener Amit Mishra. We are Group 7, which consists of Stephan Cilliers and Wren. The sensing device is to be left on ice buoys in the Antarctic in order to monitor the state of the environment on the buoy. The sensing device to be used is the ICM-20649, which contains 29 sensors for which data will be collected. Software is to be developed for running on a Raspberry Pi Zero to collect data from a sensing device, which is to be compressed and encrypted for storage on the device until it is eventually retrieved. The constraints that we're dealing with are the limitation in computing power of the Raspberry Pi, the specifications of the ICM-20649, and the environmental conditions that these hardware devices should be able to operate in. The project brief states that the usage of computation resources should be minimized in order to preserve battery life. We determined the requirements for the system and broke down the solution into various subsystems. The filtering and transmission subsystems were eventually dropped due to the scope of the project. The simulation was conducted by replacing the ICM-20649 IMU block with a data source that fetches samples from a CSV file of sample data. That way, the interface between the data source and the rest of the system remained consistent regardless of the actual source of data and required minimal changes to the code base when switching between simulation and hardware. Testing was conducted by generating datasets of various sizes instantaneously instead of waiting for the specified interval between samples. Using these datasets, the functionality of the compression and encryption subsystems was verified. The compression subsystem was tested by means of compressing, decompressing, and checking for consistency across the resulting files. Similarly, for the encryption subsystem, encrypting, decrypting, and checking for consistency across the resulting files. The overall system functionality was validated by simulating a sampling delay of 0.1 seconds and executing the processing block on the resulting data every 2 seconds. This produced compressed and encrypted files every 2 seconds, which was then decrypted and decompressed and checked for consistency with the raw data files. The scaled-down IMU used was the Pi Sensat. All that was required was the creation of an IMU data source class, which implements the required methods, i.e. fetching a sample of data from the Pi hat. This new class replaced the CSV data source in the main script, and the same test was conducted and validated.
Okay, so we're just going to test that the system works when it's actually connected to the Pi and it's taking real readings. So we're going to press make run. What this is going to do is, uses the password of pass, and it just takes a whole bunch of actual readings and batches them. So we made one batch. Okay, so then that is going to make a file called batches. We're going to go in there and we're going to open it in Excel. And while that's loading, we're going to run make reverse. And what this is going to do is it's going to take our encrypted file and our compressed encrypted file, and it's going to spit that out. And I'm actually just going to change the name just because then I can actually open it with, I can open two of them at the same time. And so yeah, let's just make sure that it actually works. Oh, there we go. And so let's just make sure that they're the same. -5, -560. I mean, I am pretty sure that these are the exact same. So that just proves that our system really does work, with the entire system in place.